Hey guys, and welcome back to our YouTube channel. So I have Gizmo here today because he wanted to say hi to all of you. So can you say hi, Gizmo? Say nice to meet you. Good boy. Can you give everyone a high five? High five. Good boy. He's a little eager. Good job. Yeah. So go ahead and say bye to everyone, Gizmo. Say bye. Say thanks for coming to our YouTube channel, but we have to go ahead and get started with our lesson now. All right, guys. So I'm going to go ahead and peace out in this little box right here. And if you can do me a favor, take out something to write with. Alrighty guys, so hopefully you have a paper and pencil because we're going to go ahead and take some notes here. Before we jump into our notes, I want us to review how to multiply expressions. So go ahead and hit pause on this video and multiply out these two expressions, and when you come back, we'll talk about the solutions. Okay, welcome back. So hopefully you've multiplied both of these expressions out, and here is what you should be getting for the solutions. So whenever I multiply two binomials, I just like to go ahead and set up my lattice box. So I put n plus 3 up here, and I put n minus 3 over on the side here. And we go ahead and we multiply that and then add like terms. If you notice, this minus 3n and then positive 3n cancel out. So your final answer is going to be n squared minus 9. And then over here for number 2, I just basically followed that same structure, and I ended up with 4v minus 16. Okay, so when I multiply those two expressions, I get the answers in the pink box, right? But if I wanted to go backwards or unmultiply, aka factoring, then the factors of those expressions would basically be what we started with, right? So these are our factors, what I've underlined in pink. Those are the factors to the expressions that are boxed in pink, right? And so today we're basically going to be factoring expressions like these two up here, okay? And there's a special pattern for that. So let's go ahead and start looking at some examples. So I want you guys to notice something. So here is the original problem I started with. And this is the answer I get when I factor that expression. Now, do you guys notice anything? Okay. So I want you to pay special attention to this first term right here. That's n squared. So the square root of n squared is n, right? And that appears here in your expression. And then the square root of 9, because 9 is a perfect square, right, is going to be 3. And then if you notice, I've got a minus sign in here, and that's going to translate into a plus and a minus down here in your expression. Same thing for number 2. So this first term right here is a perfect square. The square root of 4 is 2. The square root of v squared is v. So the square root of that whole thing is 2v. The square root of 16 is 4. Okay, this is called difference of squares. So somewhere on your paper, what I'd like for you guys to do, and I'm going to go off to the side here, this is called difference of squares. Okay, and a difference of squares means that when I've got a perfect square term as my first term and a perfect square term as my second term, and I'm taking the difference, aka subtracting the two, it's going to follow the following structure when I factor them. So I'm going to have a plus b and then a minus b. So for example, if we go back to our number 1, n squared minus 9, this was a perfect square term. 9 was a perfect square term. So when I factor it, it's going to follow the following structure, right? You're going to take the square root of both of them and then put them into their respective factors. So let's go ahead and try that out over here on the side together. So the first thing we want to do before we start factoring is just to make sure that it's in the structure that we need it to. So let's ask ourselves, is x squared a perfect square term? Yes. X times x is x squared. Is 100 a perfect squared term? Yeah, that's on our list of perfect squares, right? This is why that list is so helpful and why it might be a good idea to maybe have it written down on the side. So remember the perfect squared numbers. I'm going to write it over here. Perfect squared, get it? Numbers Our 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100, and so on and so forth, right? Those are your perfect squared numbers, and we're looking for those to appear in our expressions. So our first term is a perfect squared term. The second term is a perfect squared term. And we're taking the difference, aka we're subtracting the two, so we can go ahead and put it into our structure. Okay, so I'm going to put my 2 parentheses, plus, minus. The square root of x squared is x, and the square root of 100 is 10. So those are the numbers that I'm going to put into my factors. And then you're done. Okay, the other way that you could have written this is just x minus 10 and x plus 10. You could have just reversed the locations of those two. All right, let's go ahead and take a look at the second one. N squared minus 144. Is n squared a perfect term? Yes. Is 144 a perfect squared term? Yes. So now we can go ahead and set up our parentheses. We can go ahead and plus and minus to follow the structure. The square root of n squared is n. The square root of 144 is 12. And there you go. Those are your factors. Again, you could have written it as n minus 12 or n plus 12. Those are two good ways to write your answers. Okay. What I want you guys to do, oh wait, no, not yet. Not individual practice yet. Okay. Let's go ahead and do the next two. So m squared is a perfect squared term. 36 is a perfect squared term. And so we can factor this as m plus 6 and m minus 6. Okay, last one. Y squared is a perfect squared term and 64 is a perfect squared term. So our factors here are going to be y plus 8 and y minus 8. And those are our factors. Okay. But there is one thing I want to bring to your guys' attention. So let's take a look at this expression here that I've just circled in yellow. If we factor this following our rule, we can factor it as y minus 5 and y plus 5, or y plus 5 and y minus 5, right? Those are two valid answers. However, what we cannot do is we cannot factor it like y plus 5 and y minus 5. That will not work, and here's why. If I take y plus 5 and y minus 5 and I multiply it, because this is how we can check our answers, right? And we multiply it back out, I end up with an expression that's 25 minus y squared. And that's not what we started off with, okay? Because if I rewrite that expression in pink, that's basically negative y squared plus 25. That's not what I had written up here, right? That's not it. So when you're factoring, make sure you put the first term, like the first square root of the first term that's being squared. So for example, because y squared is the first thing you see here, your y has to go in the first place in both of these parentheses. Excuse me. Because 25 was the second term to appear, that minus 5 or the square root of 25 is going to be the second thing that appears in your sets of parentheses, okay? So it's your turn. I want you guys to try to factor the following using the rule that we just learned together. So there's 1, 2, and 3 here for you to try. And when you are done, hit pause in this video, and when you're done, we'll go over the solutions. Okay, welcome back. Here are the solutions to the problems that you guys just did. So you should have gotten y plus 7 and y minus 7, x plus 2 and x minus 2, and then w minus 13 and w plus 13. And then, of course, if you wrote them in the other way, like they are down here, then you are good to go. There is one more thing that I want to talk about, and that's something that's what if we get an expression that's like y squared plus 25. That looks a lot like our difference of squares, right? Because this first term right here is a perfect square number, and that second term here is a perfect square number, but we're not taking the difference, guys. This is a sum of squares. Remember, the rule is called difference of squares, and difference means subtraction. Okay, so if you get an expression like y plus 25, you cannot factor. Okay, so other examples of this might be like x squared plus 16, or x squared plus 225, or x squared plus 81, right? So you might see things like that, but all of these you cannot factor. Okay, those are not factorable. Not factorable. All right, so let's go back to our problems, and we're going to do one more round of these. So we're going to level up a little bit, and we're going to still factor these two expressions. So again, let's go ahead and do our checks. Is this first term a perfect squared number? Yeah. The square root of 9 is 3, and the square root of x squared is x. So I got my plus, so, and then my minus here. And then the second term over here, 25, is that a perfect squared term? And the answer to that is yes, the square root of 25 is 5. So these are our factors. You could have also written it like 3x minus 5 and 3x plus 5. Okay, that's totally valid. All right, now for number 2, 25m squared, is that a perfect squared term? Yes, the square root of 25m squared is 5m. So that's 5m plus and 5m minus. And then is 225 a perfect squared term? And the answer to that is yes. And do I have a difference here? And I forgot to check for the difference in number 1. But yes, I have a difference here. I'm subtracting both of those. So I can go ahead and follow my structure or the rule. And these are my factors. Okay. All right, guys, so for number 3, I want you guys to go ahead and try this. Hit pause in this video. When you come back, we'll go over the solution. All right, guys, welcome back. So hopefully when you factor this, you ask yourself, okay, is 16n squared a perfect squared number? And the answer to that is yes, the square root of 16n squared is 4n. So I write 4n plus, 4n minus. And then you should have asked yourself, is 144 a perfect square number? And the answer is yes. And then, am I taking a difference? Am I subtracting them? The answer is yes. So I can go ahead and factor that. So I have 4n plus 12 and 4n minus 12. And that is your solution, and you have factored it. You could factor that more, but I don't really want to right now just because I want to keep the focus of this video on difference of squares. That's pretty much all I have for you today. So go ahead and try the homework that's posted in Google Classroom. Don't forget to like, subscribe, and comment down below. Okay, thanks. Bye.